You hear the word acid, and, well, you probably instantly picture a bubbling neon green liquid in some underground chemistry lab, just eating its way right through a solid metal table.
Right, like something straight out of a comic book. It's an inherently harsh word.
Exactly. It implies destruction, corrosion, and something you absolutely need to handle wearing heavy-duty rubber gloves and safety goggles.
Yeah, and you definitely don't associate it with gentle skincare.
No, definitely not. Now, I want you to take that word and put it right next to the word babies. Acid and babies. At first glance, that combination sounds absolutely terrifying, right? Like a massive mistake waiting to happen.
It really does. I mean, it sounds like the exact opposite of what you'd want anywhere near a newborn. It triggers, well, basically every single protective instinct you have as a caregiver.
Right.
We are so heavily conditioned by decades of marketing to seek out words like soothing, gentle, creamy, or lotion when it comes to infant care. So seeing the word acid on a baby product label, it feels like a total violation of that entire rule book.
It totally does. But that is exactly what we are doing today on our deep dive. We are taking a really close look at an extensive and honestly eye-opening article from Era Organics. It was written by Nikki Chase, and we're focusing on the science of something called hypochlorous acid.
Which is often abbreviated as HOCl.
Right, HOCl, specifically in the realm of infant skincare. And our mission today is to completely demystify this. We're going to uncover why this intimidating sounding chemical is actually a natural, highly biocompatible miracle worker. We're going to equip you with the exact science of how it interacts with delicate skin so you can confidently cut through all the marketing noise of the baby product aisle and really understand what's happening on a microscopic cellular level.
Which is such an important mission because, it represents a profound shift in how we think about skincare as a whole.
Yeah.
Once you move past the intimidating chemical name, you discover that the biological reality of this substance is completely counterintuitive to what the word acid usually suggests.
Right. It's not the green bubbling liquid.
Not at all.
Yeah.
It's arguably one of the most elegant, highly targeted, protective mechanisms we actually have in nature.
Okay, let's unpack this. Before we even talk about putting anything on a baby's skin, we have to demystify what this substance actually is. And, well, when I was looking through the source material, a very specific image came to mind.
Oh, yeah. What was it?
Well, think of hypochlorous acid as a microscopic bouncer at a really, really exclusive club.
Okay, I like where this is going.
Right, because a bad bouncer, which is basically what a harsh synthetic chemical is, just throws everyone out and trashes the club in the process, breaking chairs and ruining the night for everyone.
Yeah, total collateral damage.
Exactly. But a great bouncer like HOCl specifically targets the troublemakers. It finds the pathogens, the bad bacteria, and it quietly removes them without knocking over any tables or disturbing the healthy skin cells that are, just trying to have a good time.
That is a brilliant way to visualize it. And what's fascinating here is that this bouncer isn't something cooked up in a cosmetics lab or synthesized in a factory somewhere. It's an endogenous substance.
Endogenous meaning.
Yeah.
Made inside us.
Exactly. It is naturally produced inside the human body. Specifically, it is manufactured by your own white blood cells.
Wow, really?
Yeah. Every time your body detects an invader, whether that's a rogue bacteria, a virus, or, say, a fungal spore, your white blood cells, specifically a type called neutrophils, they rush to the site. And they actually synthesize and deploy hypochlorous acid as your primary innate immune response. It is literally your body's own manufactured defense mechanism.
Wait, so just to be completely clear, if I'm at home and I get a paper cut or I scrape my knee, my own blood cells are physically traveling to that cut and manufacturing this exact acid right there at the site of the injury.
Exactly. You are constantly producing it to keep yourself safe. And the mechanism of how it works on a cellular level is it's brilliant. Well, hypochlorous acid has two very specific, very special chemical properties that make it so effective. First, it has a neutral electrical charge. And second, it has a very low molecular weight.
Okay, break that down for me.
Sure. So imagine a single-cell bacterium trying to infect a cut. Its cell wall is highly designed to repel threats. And it often uses an electrical charge, sort of like a magnetic force field, to push away harmful substances.
Makes sense.
But because HOCl has a completely neutral charge, the bacteria's outer defenses don't recognize it as a threat. It slips right past the outer gates without sounding any alarms at all.
It's like a Trojan horse slipping into the fortress because the guards just, didn't check its ID.
Precisely.
Yeah.
That's exactly it. And because of its extremely low molecular weight, meaning the molecule itself is just tiny, it effortlessly penetrates the pathogen's thick cell wall.
And once it's inside?
Once it's inside the bacteria, it destroys the invader from the inside out through a process called oxidation.
Right, oxidation.
Yeah, and oxidation isn't just like a gentle deactivation. It literally steals electrons from the bacteria. It targets and dismantles the protein structures and literally tears apart the DNA of the bacteria so it cannot replicate or survive.
Man, that sounds incredibly violent for the bacteria.
It's absolutely lethal for pathogens. But it doesn't stop there. Bacteria are incredibly smart, right? They often build these thick, slimy protective shields around themselves called biofilms to resist treatments.
Like the plaque on your teeth.
Yes, exactly like plaque. That's a classic biofilm. Well, hypochlorous acid is scientifically proven to dissolve and break down those biofilms, leaving the bacteria totally exposed.
So it strips away their slimy armor, sneaks past the force field, and then just dismantles their DNA.
Basically, yeah.
But that actually brings me back to my first worry. How does it do all that extreme destruction to the bacteria without harming the baby's actual skin cells? I mean, why isn't the club getting trashed in the process?
It all comes down to evolution. Because human cells have evolved alongside this exact substance for millions of years, our cells have built-in protective enzymes.
Oh, okay.
Yeah, so these enzymes instantly neutralize HOCl if it tries to enter our healthy cells, whereas single-celled pathogens just do not have those protective enzymes.
That is so smart.
It is. Furthermore, HOCl actually acts as a calming agent for our own tissue. It inhibits what are called pro-inflammatory cytokines.
Cytokines, those are the things that cause inflammation, right?
Yes. Cytokines are basically signaling proteins. Think of them as your body's alarm system, calling in the troops, telling the surrounding tissue to swell up, get hot, get red, and become inflamed to fight an infection.
Right, like when a bug bite gets all huge and red.
Exactly.
Yeah.
So by inhibiting those specific cytokines, HOCl rapidly turns off that biological alarm system, which visibly reduces skin redness and swelling.
Wow.
Yeah, it's neutralizing the bacterial threat while simultaneously telling the body's own immune system to calm down and just stop overreacting.
That is incredible. I mean, it really changes how you view your own immune system. But it also brings up a really obvious pushback for me.
Let's hear it.
Well, if our bodies make it naturally and the molecule's exactly the same, whether it's inside us or, in a bottle, why can't caregivers just use the adult version of HOCl they might already have sitting in their medicine cabinet?
Right.
Like if I have a bottle of facial spray for my own post-workout acne, why do I need a special baby version? Can't I just share?
That is a very logical assumption to make.
Yeah.
If it's the exact same molecule, why not just share the bottle? But doing so would actually be a massive mistake.
Really? Why?
To understand why, we have to transition from the biology of the acid itself to the structural anatomy of infant skin. Because baby skin is vastly, vastly different from adult skin.
Mm-hmm.
Baby skin is not just a miniaturized version of what you and I have. It is functionally and structurally distinct.
How so? Because, when you touch a baby's cheek, it feels so perfect and soft, you'd think it was the ultimate ideal state of human skin.
It feels incredibly soft, specifically because it is so underdeveloped.
Oh, interesting.
Yeah, so the very outermost layer of our skin is called the stratum corneum. Think of it like a brick wall, where the skin cells are the bricks, and lipids or fats are the mortar holding it all together.
Okay, got the brick wall in my head.
In infants, this layer is much thinner, and the mortar is significantly less developed than ours. Because of this, infant skin has a profoundly higher permeability. It acts almost like a highly absorbent sponge.
Oh, wow.
Yeah, whatever you put on it is absorbed much faster and goes much deeper than it ever would on an adult.
So an adult skincare product would just hit their system like a tidal wave compared to the mild tingle we might experience.
Exactly. And on top of that permeability issue, adults have something called a robust acid mantle.
An acid mantle?
Yeah, it's a very thin, slightly acidic protective film on the surface of our skin. We also produce sebum, which are natural oils that help lock in our body's moisture and physically block environmental stressors like dry air or bacteria.
Right, which is why we get oily skin sometimes.
Exactly. But infants, especially newborns, have just spent 9 months floating in amniotic fluid. They lack that robust acid mantle, and they don't produce much sebum at all yet.
So they have basically zero natural defense against drying out.
Right. They lose moisture incredibly rapidly to the air. This means if you take a high concentration of hypochlorous acid meant for an adult's thick, oily skin and spray it on a baby, it will cause mild irritation or severe overdrying
Yikes.
because their skin simply doesn't have the structural defenses, the acid mantle or the sebum, to handle the adult dose.
Okay, so how do the pediatric manufacturers account for this massive structural difference? Are they just taking the adult stuff and watering it down?
It's much more precise and scientific than just diluting it.
Hmm.
Pediatric manufacturers create this solution through a very specific, highly controlled process called the electrolysis of salt and water.
Electrolysis, so using electricity.
Yes, they take a simple saltwater solution, just H2O and NaCl, and they run a highly calibrated electrical current through it.
Okay.
This electricity literally breaks apart the molecular bonds of the water and the salt, allowing the hydrogen, oxygen, and chlorine atoms to recombine into a stabilized medical-grade version of hypochlorous acid.
That's fascinating.
It is. But the key to making it safe for babies is that they tailor the output specifically to a pH balance of 5.5 to 6.0.
Which, if I remember my biology correctly, perfectly matches the natural ideal acidity of healthy infant skin.
Exactly. They perfectly match the pH, and they keep the concentration of the HOCl strictly controlled, usually between 50 and 200 parts per million.
Okay.
This ensures it remains perfectly biocompatible. It provides all of those incredible antimicrobial bouncer-like benefits we talked about without compromising that fragile, highly permeable, sponge-like dermal layer.
Because their skin absorbs everything like a sponge, they are infinitely more vulnerable to chemical reactions. And honestly, there is no harsher chemical reaction on a baby's body than what happens inside a dirty diaper.
Oh, absolutely.
Here's where it gets really interesting, though, because understanding the molecular structure is great theory, but how does this specialized baby formula actually perform in the real world?
Right, where it actually counts.
Yeah, I mean, any caregiver listening to this knows the absolute panic of a 3 a.m. diaper change. Your baby is screaming, their skin is bright red and raw, and the traditional playbook is to just spackle on these thick, incredibly heavy white zinc barrier creams.
Which is such a mess.
Right. You're basically frosting a cake, trying to block the moisture, and then you have to somehow scrub that paste off at the next change, which just hurts them more. So how does HOCl actually change that game?
It completely changes the game by addressing the actual root cause of the trauma rather than just building a physical wall over it.
The root cause.
Yeah. Diaper rash isn't just about wetness. It's an aggressive chemical reaction. It stems from prolonged exposure to moisture mixed with fecal enzymes and ammonia from urine. And those aggressively burn and break down that already fragile infant skin barrier we just talked about. When you apply HOCl to the diaper area, it doesn't just sit there. It actually neutralizes those fecal enzymes and moisture irritants right on contact.
Wow, it's literally disarming the chemical bomb before it can go off and burn the skin.
Yes, exactly. And more importantly, by instantly reducing the microbial count on the surface of the skin, it creates an environment that is incredibly hostile to Candida albicans.
Candida. That's a yeast, right?
Yes, it is the specific strain of yeast that is responsible for severe, stubborn diaper dermatitis.
Ugh, the worst.
Right. And when caregivers use those incredibly thick barrier creams you mentioned, they trap moisture to keep urine out. But if yeast is already present on the skin, you can sometimes accidentally trap the yeast against the warm skin.
Oh no, creating like a greenhouse effect.
Exactly, creating the ultimate breeding ground for an even worse infection.
That's terrifying.
But HOCl clears the canvas entirely. It kills the yeast, neutralizes the enzymes, and significantly reduces the need for those heavy, impossible-to-wipe-off creams in the first place.
That is a lifesaver. And what about when the skin is actually broken? You know, the inevitable minor cuts, the scratched faces from their own sharp little fingernails, or scraped knees as they start crawling and exploring the house?
The clinical applications for minor wounds are remarkable. When you introduce hypochlorous acid to an open wound bed, it doesn't just clean it and kill the bacteria. It actively increases oxygenation and blood flow to the affected area.
That's cool.
But the truly amazing part, and where the science gets really cool, is its interaction with fibroblasts.
Fibroblasts. I've definitely heard that term in like high-end skincare commercials, but remind us what they actually do inside the body.
Think of fibroblasts as the microscopic construction workers of your skin.
Okay, construction workers.
They are the highly specialized cells responsible for creating new connective tissue, synthesizing collagen, and essentially building the scaffolding needed to close a wound.
Got it.
Studies show that HOCl actually facilitates the migration of these fibroblasts directly to the injury site. It stimulates tissue remodeling growth factors.
That is wild.
So it's not just keeping the area sterile, like, say, rubbing alcohol would. It is actively handing blueprints to the construction crew, accelerating the natural regenerative timeline of the dermis so the wound closes faster.
It's literally like the bouncer clears out all the troublemakers and then turns around and hands a blueprint and a hard hat to the construction crew to come fix the broken door.
That's a perfect way to visualize this sequence of events.
I love that.
And there's another major clinical benefit we need to cover, particularly for babies who suffer from unexplained rashes, eczema, or aggressive reactions to other skincare products.
Okay, what's that?
We mentioned earlier how HOCl inhibits cytokines to stop redness, but it also actively downregulates the activity of mast cells.
Mast cells, are those the cells primarily involved in allergies and allergic reactions?
Exactly. Imagine mast cells as tiny chemical landmines scattered all throughout your skin.
Landmines, okay.
When infant skin is exposed to harsh laundry detergents, synthetic fragrances in supposedly gentle baby wipes, or harsh preservatives in baby soaps, those landmines are stepped on.
Cool.
Right, the mast cells are triggered and they explode, releasing a massive flood of histamine.
And histamine is the chemical that causes that immediate, angry, hot, red itchiness.
Yes. HOCl downregulates those mast cells, effectively defusing the landmines and cutting off the histamine release right at the source.
Wow.
It physically stops the itch and redness caused by allergic reactions, essentially neutralizing the residual chemical irritants left behind by other, harsher baby products.
So what does this all mean for the exhausted parent or caregiver's daily routine? Because understanding the miraculous cellular healing and the histamine suppression is fascinating, but, we need to know exactly how to apply it safely.
Of course.
And I actually have to push back here because simple logic dictates a potential problem.
Oh.
Wait, if this is an aqueous acid solution, meaning it is entirely water-based, doesn't water naturally evaporate?
It does.
And if I spray water on my dry hands in the middle of winter and just let it dry, my hands get infinitely more chapped. Doesn't water evaporating off the skin inherently draw moisture out of parched skin? How on earth is this actually safe for babies who already have severe dry skin or eczema-prone skin?
You hit the nail on the head.
Yeah.
That is an excellent observation, and it highlights a crucial point that caregivers absolutely must understand.
Okay.
Yes, hypochlorous acid itself does not provide any moisture whatsoever.
None.
None. It contains no lipids, no ceramides, no oils, and no hydrating properties. It is essentially structured water.
Got it.
If you just spray it on severely dry skin and walk away, the natural evaporation process can absolutely pull moisture out and exacerbate dryness.
So my winter hands analogy was right.
Spot on. That is exactly why following a specific 4-step routine is absolutely vital for safety and effectiveness,
Right.
especially for babies with eczema-prone skin.
Okay, so if I'm an exhausted parent trying to navigate this without making my kids' eczema worse, what is the actual step-by-step playbook here? How do we start?
Step 1 is to thoroughly cleanse the area. The skin must be free from any heavy barrier creams, old lotions, or thick natural oils,
Why is that?
because those products act as a physical shield. They will actively prevent the HOCl from actually reaching the skin surface where it needs to do its work. You want to use a gentle, entirely fragrance-free cleanser to prep the site.
Makes total sense. You have to give the HOCl a clear, unobstructed path to do its job. Step 2.
Step 2 is to spray the HOCl lightly over the area. You just hold the bottle a few inches away and apply a fine, even mist.
And then rub it in.
No, actually. There's absolutely no need to rub it in, wipe it, or rinse it off. In fact, wiping it with a towel immediately removes the active ingredient before it has time to work.
Oh, I see.
Once it completes its job, it naturally dissipates back into simple, harmless salt and water.
Got it. And step 3, I'm guessing this is where we finally address the evaporation and dryness issue you validated earlier.
Yes. Step 3 is arguably the most important for dry or eczema-prone skin. You must let it air dry completely.
Air dry completely.
You have to allow the antimicrobial properties a full minute or two to interact with the skin surface and do the work of killing the pathogens. But you absolutely cannot skip step 4,
Which is?
which is to immediately follow up with a rich, baby-safe, emollient moisturizer.
Ah, okay.
Applying that thick balm or lipid-rich lotion over the completely dried HOCl acts as an artificial sebum layer. It locks in the body's natural hydration and completely prevents the drying effect of water evaporation you just mentioned.
Ah, so it's a 1-2 punch. First, the HOCl neutralizes the irritants, the yeast, and the bacteria causing the underlying inflammation. Then you use the emollient to rebuild the physical moisture barrier right on top.
Exactly.
How often should caregivers be running through this four-step routine?
For general skin issues, mild eczema flare-ups or minor scratches, applying it 1 to 4 times daily is standard.
Okay, 1 to 4 times.
For an active, severe diaper rash, you might realistically use it every other diaper change to keep the yeast at bay.
Makes sense.
However, there is a caveat. For newborn infants under 1 month old, their stratum corneum is so brand new and highly permeable that a very conservative approach is required.
So even less frequent.
Yes, you should use it no more than once daily or every other day just to ensure their natural developing microbiome isn't overly disrupted while they adapt to the outside world.
Okay, so we've got the routine down, and the science makes total sense. But this brings up something I saw floating around in the sources that genuinely alarmed me.
The DIY stuff.
Yeah, because HOCl is fundamentally made from just salt, water, and electricity, there are a lot of viral tutorials online right now showing people how to hack the system and make it themselves at home with DIY kits.
This raises an incredibly important question about sourcing, and the warning here cannot be overstated. DIY homemade hypochlorous acid is incredibly dangerous, particularly for infant skin.
Because you can't guarantee you have the right concentration of parts per million in a kitchen setup.
It is far worse than just getting the concentration wrong.
Wait, really?
Yes. To create a medical-grade HOCl that is truly biocompatible, you need highly precise laboratory equipment to maintain chemical stabilization and hit that very specific concentration of 50 to 200 parts per million.
Right, you mentioned that earlier.
If the pH balance is off by even a tiny fraction of a margin, or if the solution is chemically unstable, it doesn't just become weak or ineffective water. It rapidly degrades and converts into sodium hypochlorite.
Which is literal household bleach.
Exactly. A slightly botched homemade mixture can easily and rapidly turn into harsh, irritating, corrosive bleach.
Oh my God.
If you apply that to the highly permeable, fragile, sponge-like skin of an infant, you are risking severe chemical burns, immense pain, and significant dermal trauma.
That's horrifying.
Regulatory guidelines are incredibly strict about manufacturing this for a reason. You must use commercially manufactured pediatric-specific products that clearly state their concentration on the label and are verified to be free from added fragrances or chemical preservatives.
So it's just not worth the risk.
The extreme risks of improper chemical dilution at home absolutely outweigh any minor cost savings.
That is a genuinely terrifying thought, but such a crucial warning for anyone listening. Do not experiment with homemade chemistry on your baby's skin. Just stick to the medical-grade, laboratory-stabilized formulas.
Absolutely.
Well, we have covered a massive amount of ground today. We've taken a deep dive into how a substance with the incredibly intimidating name of acid is actually an endogenous immune defense crafted by our own white blood cells. We've learned how it safely slips past force fields to target pathogens, dissolves bacterial biofilms, acts as a blueprint guide for fibroblasts to rapidly heal wounds, and even acts as an off switch to diffuse histamine landmines to calm allergies.
Provided it's a stabilized medical-grade formula, properly layered under a rich moisturizer, of course.
Right. Can't forget step 4.
And stepping back, it really fundamentally changes how we view skin health and healing.
It really does.
It proves that the most effective antimicrobial treatments don't always need to rely on harsh synthetic chemicals or burning alcohol that sting, damage healthy tissue, and cause a baby to cry.
Right. And that is exactly why this matters so much, even if you are listening to this right now and you don't even have a kid or aren't currently caring for an infant.
Exactly.
It is a masterclass in biomimicry. We are finally learning that the ultimate solution to fighting infection and irritation isn't to invent some newer, harsher chemical weapon to wage war on the surface of our skin.
No, it's not.
It's to study and mimic the sheer brilliance of our own biology. It's trusting the microscopic bouncer that our bodies already know exactly how to make.
And if we connect this to the bigger picture of human health, it leaves us with a truly profound possibility to consider.
What's that?
Well, if we can successfully bottle the exact molecule our white blood cells use to fight infection and use it to miraculously heal our skin from the outside in, what other endogenous substances, things our bodies are already manufacturing silently inside us right now, might hold the key to the next generation of medicine?
Wow.
Could studying and mimicking our own biology eventually replace synthetic pharmaceuticals altogether?
It really makes you wonder what else we're capable of healing that we just haven't figured out how to bottle yet. Next time you see the word acid, maybe you won't picture a bubbling green vial of destruction burning a hole through a table.
Definitely not.
Maybe you'll picture the perfectly tuned, quiet machinery of your own immune system doing exactly what it was designed to do.